Alrighty guys, so you have two worksheets today. You've got describing Earth's plates and you have a reading guide. Now this is what the virtual looks like. Your reading guide looks your describing Earth's plates looks exactly like this, except it has a picture and whatever. I wanted to read through this with you and then kind of let you mark what you think is true or not. Now, this is not a right or wrong answer type thing right now. What this is to figure out what you know about plate tectonics and the Earth's plates. So, what do you know about Earth's tectonic plates? Put an X in front of each statement that describes Earth's location. If you're in virtual, just type an X into those spots. If you're in actual class, just put an X with your mark or your pencil. So, A, plates are huge, rigid slabs of rock. Rigid means very hard, unmoving. B, plates are different sizes. C, plates are all about the same thickness. D, plate boundaries for most of the coastlines of the world. That should say form. Plate lines form most of the coastlines of the world. E, plates move very slowly. F, plates float on top of hot liquid magma. G, some of the plates have large gaps between them. H, plates can include both continental crust and ocean basin. So continental crust is simply like land, and ocean is like ocean floor. I, plates are stacked in layers, like one on top of the other, like a layer of a cake. J, each plate forms a continent. K, plates cover most of Earth, but not all of it. L, patterns of earthquakes and volcanoes can be found along plate boundaries. So plate boundaries are where plates touch each other. M, plate boundaries can be found in the middle of the ocean. N, plates are made up of hot material. O, plates are found deep within the earth. And P, mountain chains are formed along plate boundaries. So you can pause this video if you need to, go back, take your time on answering these. I want to see what you really know. Then I want you to explain your thinking. Describe what you know about Earth's plate tectonics. Give me like 2 sentences. You know, surely you know something. I'm not going to accept just I don't know anything. You guys are in, 9th, 10th grade, 11th grade, and 12th grade. A lot of you have had some sort of earth science. So, do your best on this, and let's look at the pause it if you need to, finish this up, and I'm going to read the reading guide to you here shortly. Alright, here's the reading guide. Again, this is what it looks like on the virtual side. Your paper copy does not look like this way. It's the one I typed it from, though. And you need to answer the highlighted questions. You don't need to worry about the things I put an X through. Alright, so plate tectonics, continental drift. Before you read, after you peel an orange, can you fit the pieces of the peel back together again like a puzzle? Why or why not? Mark the text. Highlight the major ideas in each section. If you're in class, this needs to happen. Go and get a highlighter from the box and highlight as you go through what you think is important. We've done this before together, so I trust that you can do this. If you're virtual, just highlight it with your cursor and put a highlighter mark over it. Evidence for continental drift. Take a look at a map of Earth's surface. Look carefully at the shape of each continent. The continents look like they might fit together like puzzle pieces, don't they? People throughout history have noticed this and wondered what it means. For example, Over 400 years ago, Abraham Ortelius, a Dutch map maker, notices that the coastlines of South America and Africa fit together. Have you ever been to Pangaea? In 1912, a German scientist named Alfred Wegener proposed that the continents did at one time fit together. He suggests that the continents did at one time fit together. He suggests that all continents were once connected. Wegener said that they once made one big landmass. He called this landmass Pangaea, which means all land. According to Wegener, about 200 million years ago, Pangaea broke into pieces. The pieces drifted away from each other. We call these pieces continents. Wegener's hypothesis is called continental drift. Continental drift is the hypothesis that Pangaea broke apart into continents that moved slowly to where they are today. So even though you haven't visited Pangaea, the area where you live probably was part of Pangaea millions of years ago. Let's do the picture this. Trace over the boundaries separating the continents on the map. Now, the virtual guys, this may or may not be a drawing. Double click on it. If it opens up the drawing board, you're good to go. If it doesn't open up the drawing, it's not that big of a deal. Just skip the question. Those of you in class, use your highlighter and trace over boundaries. Remember, boundaries are like, let's say you have two pieces of paper. That's a boundary where they touch. So trace, I'll give you an example. Here's a boundary between North America and Eurasia. So trace some of the other boundaries that you see. Did everyone accept Wegener's idea? Wegener's hypothesis on continental drift was a controversial idea. Controversial basically means that there are two sides of it and people don't believe you. And some people say, yes, it did happen, and some people say, no, it didn't happen. It caused a lot of arguments. Wegener didn't convince people that his ideas were right during his lifetime. He didn't have enough evidence. For example, he couldn't explain what made the continents drift. He thought Earth spinning on its axis might cause the continents to plow through the ocean floor. But geologists and physicists of that time rejected this hypothesis. Wegener's basic idea wasn't accepted until long after his death in 1930. More evidence came later to support his ideas. Let's do a reading check. Explain. Why didn't Wegener convince people his ideas were right? How do animal fossils support continental drift? Animal fossils offer one clue that the continents might have been joined together millions of years ago. Fossils are the remains, imprints, or traces of prehistoric organisms. Fossils can tell where and when and where organisms once lived and how they lived. For example, fossils of Mesosaurus have been found in South America and in Africa. Mesosaurus is a reptile that lived on land and in fresh water. How could this reptile move between continents separated by a salty ocean? It's not likely that it swam across the Atlantic Ocean. Wegener's hypothesis of continental drift proposes that Mesosaurs lived on both continents when they were joined together. The map shows where fossil remains of different animals have been found on different continents. So, I know on the physical copy I printed off, I have the continents labeled. So, this is Asia. This is Australia. Okay, this is Africa. Here's Europe. Here's North America, South America, and Antarctica. All right. So, it's saying, look, this is a little mesosaur, this dude that I'm coloring, and this little dude's both a mesosaur. If you notice, look how the shape of this continent and the shape of this continent look awfully close, like a puzzle piece. Looks like Africa would have just been right on top of South America at one point. So it says, let's do the picture this. Apply. Fossil remains of the extinct... Let me erase those. Fossil evidence of the extinct Glossopteris have been found in Asia, Australia, Antarctica, Africa, and South America. Add a leaf symbol in these areas on the map to represent Glossopteris. So, on these continents, right here, add a little leaf structure. I don't really care what your leaf looks like, okay? For those of you on virtual, you might not be able to do this. Sorry. You could do everything else, but the ones with drawing are a little bit harder. All right. How do plant fossils support continental drift? Another fossil that supports continental drift is Glossopteris. Fossils of the plant are found on 5 continents: Africa, Australia, Asia, and South America, and Antarctica. Finding Glossopteris is in so many areas supported the idea that all of these regions once were connected and had similar climates. What does climate tell us about continental drift? Scientists have found fossils of warm weather plants on the island of Spitsbergen in the Arctic Ocean. This is one of the coldest places on Earth. How did this happen? Wegener's hypothesis of continental drift proposes that Spitsbergen Island drifted to the Arctic from a tropical region of Earth. How do rocks support continental drift? Glaciers are large, slow-moving bodies of ice on land. Glaciers leave tracks as they move, scouring and polishing rock surfaces under them. They also leave deposits of glacial rock and sediment. Glaciers are found in cold areas, yet there are traces of glaciers and deposits in many tropical and temperate regions of the Earth. How is this possible? Let's answer the reading check question. Identify. What do glaciers leave behind when they melt? This is in the reading, by the way. Wegener's hypothesis of continental drift says that millions of years ago, some tropical and temperate lands had cold climates and were located near Earth's south pole. These continents were joined together and partially covered with ice. When the continents drifted apart into warmer climates, the glaciers melted away from these areas. The glacial deposits left behind to add more evidence to support continental drift. What do rocks tell us about continental drift? If the continents were connected at one time, then the rocks located where the land broke apart should be similar. Similar rock structures are found on different continents. For example, rock structures found in the Appalachian Mountains of the eastern United States are similar to rock structures found in Greenland and Western Europe. Some rock structures in Western Africa. Rock clues like their support the idea that the continents were connected in the past. Let's answer the reading check. Explain. How do rocks provide evidence for continental drift? How could continents drift? Wegener used clues found in rock, fossil, and climate to support the hypothesis of continental drift. The computer model below shows how the continents might have drifted over millions of years. But Wegener was not able to explain why the continents broke apart. Most importantly, he couldn't explain what caused the continents to break apart. Wegener hypothesized that the continents plowed through the ocean floor. He thought that the spinning of the Earth on its axis might have been the cause. He couldn't prove his idea with facts. Physicists of his day thought he was wrong. The idea was rejected because it was too unusual. Today, there's more evidence of continental drift. After Wegener's death, new technology provided new evidence. New ideas about continental drift were developed. One of these ideas is known as seafloor spreading. Let's do the picture this. Label Find North America on each of the 3 drawings below and label it. Again, if you can do it on virtual by clicking on it and adding text boxes over the picture, go ahead. But if you can't, don't worry about it. So I'll do the first one for you, and then you can do the rest. So North America is right here. And South America is here. So can you see that on the other pictures? All right, if you guys have any questions, I'll be there Thursday to answer them, okay? Don't worry about if you don't finish this, we'll work on it in class on Thursday when I get back. I'll talk to you guys later.